Hey folks, hope everybody's doing good. We can get started here. Um, Looks like we've got a question already. Here, let me just adjust my screen capture a little bit. Actually, probably the text size needs to be increased. That'll do. Spread that out a little bit. Okay, cool. So it looks like we already have a question to go through. If I could go through a walkthrough of how to do the myDulo function. All right. This is in the advanced problems, and it's basically, if memory serves, well, I guess we'll see this. I recall helping some other people with this question a while back. So if memory serves, this is a sort of manual implementation of a modulo function. 5, 6. Okay. Cool. I don't recall how I solved this before, so we'll see. I know I have done it. There's my tests. We'll start with those, and I'll just pull this in. Oops. So, always good to just get everything ready ahead of time. Get all your stuff laid out. Here, I'm going to, decrease the text size a little bit. It's a little too big for me. Let me know if it needs to be, let me know if the text size needs to be increased. I know the resolution is low on the videos, and I'm sorry for that. It's given the constraints of my machine and my internet currently, that's a necessary thing, but my machine, I will be upgrading my machine soon. And hopefully that won't be a problem. Okay, and then let's just check this link out. I think this is a spec for a modulo. Yeah, that's what that is. Okay. We might need to look at that. Okay. So let's just get our scaffold. Def modulo takes in, we'll just say n and m. And we'll have res equals 0 and return res. Oh, good. Okay, cool. And I'm trying to think. We should call these. N and M is fine for now. And I'm kind of setting this up as an accumulator pattern problem. I'm not sure if I need to do that though. We'll see. We shall see. Yeah. So let's read through the problem statement. We'll talk about modulo, kind of look at some of the notes on how it works and stuff like that, and we'll go from there. Okay. So write a function called myDulo. Given two numbers, myDulo returns the remainder after dividing num1 by num2. It should behave as described in the Python documentation for the modulo operator given in this section. Okay. Cool. And I'm just going to do something with my tests here. I'm actually, since I've got quite a number of tests, I'm going to actually print out the result. I'll usually just keep it as a comment at the end of the line like that. No particular reason, just that that's usually what I do. But in this case, I'm going to print them out so that I don't have to like parse by eye like which result I'm looking for in this, since I have quite a number of tests. So that way, what I'm going to see, well, let's just run it and we'll kind of look at this. So I have what my function is returning on the left. I'll expand this a little bit. So this left column is, this is the result of all those prints, and the left is what the function is currently returning, which is just 0. And then the right is the expectation given those inputs. So yeah. Once these match, once I'm getting the same thing for these, then we can go from there. Okay, cool. So I'm thinking about how to do this just procedurally. And the way to approach this, I mean, we've got what, 1, 2, 3, 4, 5, 6, 7, 8 tests, which is great. It's always good to have plenty of tests. Usually I'll just write 1 or 2 if I'm writing them myself for a small problem. But if you have a lot of edge cases, a lot of things that you want to make sure a specific scenario is going to be handled correctly, it's good to have at least 1 or 2 tests for each of those. You don't have to go hog wild and write 8 every time. At least have 1. Usually 2 makes sense, but having plenty of tests is always good. So let's see here. So the first thing I like to do, the way to approach this, rather than trying to think about all 8 of these tests, all 8 of these tests at once, I'm just going to comment out all of them but the first one, and just focus on one at a time. And at some point, usually kind of once you get it, once you kind of get the right logic, all of them will start passing. But sometimes you got to work through one at a time. You'll get one test to pass, and then you'll work on the next one, and sometimes you'll get that test to pass, but you'll break the previous test, and then you got to get them both to pass. And then usually once you do that a couple times, then they're all passing, but we'll see. So I have an idea in my head, which is, I'm thinking if I have a for loop, I can just have like some sort of counter, and count in increments of m, I think. Because oh gosh, I always get this backwards. Dividend divisor, yeah, dividend divisor quotient. So the name operators and the result of a division operation is you have the dividend over the divisor. I've gotten that backwards. I believe it's the dividend over the divisor, and then the result is called the quotient. So on the left-hand side, we'll have the dividends. So at any rate, we'll have n on the left and m on the right. We'll just treat it that way. So this is like saying, what's the remainder of 25 divided by 4? So if I take 25 over 4 and get the remainder, I should get 1, right? And we can think about that. So I don't need to count in increments, right? I'm thinking of how to do division, not modulo. But I could count in increments and see how many times I can count in increments up to 4 and get whatever that sum is without going over 25. So that sounds like probably use a while loop. But I also might be able to have a for loop in a range. And that might be good as well. Yeah, so I think I'll try the for loop solution first. Yeah, I'll try the for loop solution first, and we'll just go from there. So I'm going to say for inc, which is for increment, in range. And what do I want to do the range of? I'm just going to do range in. And we'll say res plus equals res plus equals inc, our increment, right? And I have to specify an increment. So I'm going to start at 0, and I'm going to go up to n. And I want to go in increments of m, I believe. Yep. So I'm going to essentially be adding the increment every time. You know, which I can actually just do with m. And then I can see if res is greater than n. And I've actually gone too far, so I actually want to back this off. And this is kind of just a real hacked together algorithm. I mean, I plan on reformatting this. This doesn't feel totally like a great way of doing this yet, but that's okay. We're just exploring. We'll do that. So if res at any point is greater than n, we're going to actually back res off by 1 increment of m, and we'll break the loop after we decrement like that. So I'm just going to run this and see what res is. So I should expect or 5 times 4 is 20, plus another 4 is 24. So 4 times 6 is 24. So I should see res equal to 24, I believe. We'll see. Okay, so I got 24 and I expected 1. So what I can do is n minus, so n is 25, 24, so now it's just the difference, right? So the remainder is just the difference with what I got to what I was expecting. Okay, n minus res. And remember, my whole goal here is to just get this first test to pass, right? I'm looking at this code and I'm like, yeah, this is gonna work, at least for this test. But we're getting this by approximation. And this is a workflow that I often like to use. Okay, cool. So didn't quite work for this one. If you notice this, right, we got 1007 and we were expecting -7. And that's because we've got this behavior where we've got 1007 and we're saying -13. Yeah. So 1007 times or over -13 has a remainder of 7. Okay. That's an odd one. So you know what I think I want to do? I want to come to the sort of negative cases later. So I think I'm just going to collect everything that doesn't have a negative number in it, and we'll just see at least if I can get it to work for those ones, and then we'll come back and do the negative ones. I remember going through this before when I helped someone else out with this. I do not remember what I did. That's okay. Okay, so we've got all positive numbers here. 1, 1, and 6. Okay, so it's working for all positive cases. So this works for all positive cases, which is nice. That's something. So let's see. So I think I want to sort these into cases where the left hand operand is negative in cases where the right-hand operand is negative. I don't see any cases where both are negative, and that's a case that we're not actually testing for here. Okay. So here we have 1007 over negative 13. Here we have 7 over negative 3. This seems like an easier case to think about than the other one. So I'm going to swap these because I want to test that one first. I want to do the easier one first. Okay. We'll do the same thing here. We'll work up towards the hard ones. Okay. Oh, I already tested that. All right, so these are all my positive cases. Positive numbers. These are all my right negative. And these are all my left negatives. Cool. So let's just try a right-hand negative. I know the left-hand negatives were failing, but... Okay, so I got 7, but I was expecting negative 2, right? And this kind of makes sense, because I'm seeing if res, I'm incrementing res by m. M is negative 3, so 0 plus equals negative 3 is negative 3. If negative 3 is greater than n, right? I think what I'm going to end up doing here is just exhausting this loop, and it's going to break because it exhausts that loop. So in order to see if I'm ever hitting this point, I'm just going to print something in this condition. I'll just say here, right? I'll know if I see that here printed, it's going to run that line. And it didn't, right? So this is going to decrement, let me print inc. We'll print the increment. And it looks like we're just going to get one iteration, right? Right, because we're taking negative steps in a positive direction. So this is actually going to be 7 minus 0, since this loop is never going to run in this case. I'm not really feeling the for loop anymore. It does work for the positive cases. So I'm thinking maybe instead, maybe you could step this back and use a while loop. So I had the idea for a while loop before, so let's just try that. And to be honest, I think I'm just gonna, I'll stash this down here just in case we want to reference it, but I think probably just get rid of it. Okay, attempt 2. So while, we'll say while and what do I want to do here? I want to see how many times m goes into n. Yeah. So the question is, how many times does negative 3 go into 7? Well, let's ask. Print, let's just print 7 over negative 3. Negative 2. Negative 2.3333 repeating. Okay. So that appears to be, if I take this and multiply it by negative 3, of course that's got to be a negative, I should get something close to 7. 6.999 is close to 7. Okay, good. Yeah, okay, 7.0. Okay. So that's what that equals. And then the remainder, wow, what a weird problem. The remainder, right. So negative 2, right. So negative 2 times 3 times negative 3 gives me 6. And am I expecting 1? No, I'm expecting negative 2. Oof. But if I do 7 mod 3, mod negative 3, negative 2. Okay, cool. So I think I'm approaching this in a strange way. I'm starting to think, you know, there's probably an easier way I could be approaching this. So yeah, I know I can, if I do 7 over 3 as an int, let's just try this. 7 over 3 as an int is going to give me negative 2. Okay. And that's sort of a coincidence that is also the remainder. It's a coincidence in this case. So I think I could do, if I multiply this times, what do I need to multiply that times? Times negative 3. That's going to give me 6. And then if I'm so close. What about the remainder of plus 1 added back to the divisor, which is negative 3? All right. Okay. This is a good one. I remember with this one, I am remembering helping it. Like I said, I helped somebody with this one a while ago. And as I'm recalling that session, it was a mentoring session with somebody. I remember the answer kind of came to me in a flash, but it's not coming at the moment. So, but that's okay. I think we'll just print our way there, basically. So, and I think we can do it this way, essentially. If we multiply that times negative 3. And I should actually be plugging in. I'm actually just going to return this. We'll do that. Okay. And this should be I don't need these up here. I want to move them down here. Okay. That's easier. Okay, so this is n and this is m. Okay. So int n over m times m is this minus, and if I did, I mean, I'd get close. Try this again. Okay. This is -2. We have a negative remainder. Let's try this. Hmm. Okay. I feel like I need to read through these notes again. Okay. So do not use either of the actual built-in modulo operators, mod or %sign anywhere in your code. We have 0 mod a number equals 0, number mod 0 equals none. Okay, so these are some edge cases that we want to handle. But those aren't being tested for here. I maybe do just want to handle that as an edge case. And we'll just say if 0 in n or m will return, oh, actually these are different, right? We'll say if m equals 0, return none, and if n equals 0, return 0. Okay, that's one thing. If either operand is none or not a number, then the result is none. Modulo always returns the sign of the second operand. Aha, okay, well that's useful. The sign of the second operand, even if the remainder is 0. Interesting, okay. So always returns the sign of the second operand. Yeah, that's interesting. So we're dealing with, well, that's interesting. It gives me something slightly different. Yeah, okay. So it looks like I do need to use floor division here. Right. So if I do this, we'll do this times m. is 9. And I think it's this. Well, we'll try this, minus n. Okay. And then I'm just going to do this. Cof equals 1 if m greater than or equal to 0. We'll just say it can't be equal to 0 because we're handling that up there. So if m greater than 0, cof equals 1, else negative 1. And we'll do this. We'll take all that and multiply cof times that. Okay, we'll try this. We'll see. Okay, both of my right-hand negative cases are working. Let's test my positive cases again. I'm getting negative numbers there as well. Okay, but I'm getting the right numbers. So it looks like cof is not working as intended there. So let's try it without cof, and we'll just see. So these bottom 3, I want to see if that's working. Okay, so those are going to be negative numbers either way, which is interesting. Wait, do I just multiply it times negative 1 either way? And that'll get both of those to pass. Okay, all right. So what about my left-hand negative cases? We'll see. Looks like it's all passing. Okay, let's verify this. Negative 2, negative 2, negative 7, negative 7, 2, 2, 4, 4, 7, 7, 1, 1, 1, 1, 6, and 6. Okay, looks like it's all passing. We didn't need the cof code at all. We just needed to multiply by negative 1. And let's just see if this is actually going to accept this. I'm a bit hopeful, but I don't know. I'll believe it when I see it. Oh, okay. Failed something. Oh, wow. Interesting. So this says unsupported operand types for / between none type and int. So they're really serious about this type checking thing. So I think what I want to do is, what did this say? If either operand is none or not a number, then the result is none. Okay, so this is where I'm returning none. So there are 2 other scenarios. So I can say or type m not n. We'll check for membership in a tuple of int and float. And we'll do exactly the same thing for n as well. Actually, we'll do m there and n over here. This is getting to be a long line, so I'll just put that there. Okay, let's try that again. Okay, so that was it. It just wanted that type checking. It's a little bit of a beast there. I didn't expect, because this is about building modulo, so I wasn't expecting the type checking to be seriously enforced. I was just thinking, okay, well, maybe this is just part of the modulo spec, but in order to get this to work, evidently I have to do the type checking as well. And if you're curious what I just did here, if I have ors or ands, if I end up with kind of a long condition, I like to break it out so that there's only one condition on each line. It's just, I find it easier to read that way. And if I see this if or like if and or something like that, I know that this is part of one greater condition. It's just kind of something that I personally like to do. If you want to break, because Python will throw a syntax error if I just break that line in the middle like that. So if I want to break that line without it throwing a syntax error, I can put a backslash at the end of the line. You have to be careful. There can't be a space after this or anything else after it. It has to be right at the end of the line. And what that'll do is just tell Python to just say, hey, yeah, I know there's a line break there. Just ignore it and pretend like this is on one line. So if you put a backslash at the end, it's just going to ignore that line break. So I did that there, and that's what's going to allow me to break this onto multiple lines. I didn't change. I just wanted to mention that because I didn't change the logic of how the problem works or how the solution works. Just changed the layout. And just to prove it, we can run that again. Cool. Hopefully that helps. And one thing I want to highlight here, you see how I don't know the answer off the top of my head, and I want y'all to start thinking about this programming in general as not something that it's not like you implement a solution that you have fully realized every time. It's like programming is a process of discovering the solution, right? Like that's what programming becomes, right? You can use Python to help you figure out the solution, right? So you can see I just printed my way there. I just kind of guessed and checked and got my way there. And I mean, at this point, this system has never let me down. You know, you can kind of crawl your way towards anything, and it works. You know, you can see that was a little took me a little bit of time, but wasn't terribly long, right? And you know, maybe I could hold myself to be more studious and think about this more critically and like really try to brain it out better. But I like showing solutions like this. I like showing like, hey, there's a time and a place for that, but you can also do this. You don't have to rely on like a fully realized solution before you implement your code. You can be like, well, I know this might get me a step closer, and then maybe this will get me a step closer, and then that didn't get me a step closer, it get me a step further away. Okay, back it up. Maybe this will get me, right? You can triangulate an answer. Like I said, it's never let me down thus far, so cool. That was fun. That was a nice challenge for once. Thank you for the question. And it looks like we have a comment from the person who asked, thought if you perform standard division, then isolate the decimal. Oh, okay, this is just regarding the solution. All right, let me know if that was helpful, or if you have any follow-up questions to that. Feel free to ask, and not just the person who asked the question, but anybody else too. Okay, cool. So I don't see anything else posted for questions for now. So I think we'll just move on and go through some of the material. Functions versus methods. Okay, so we're in a new section today. Actually, let me see if I can go back. try to give an overview of where we're at in the material if you want to follow along. Yeah, sure thing. It'll take me a few reviews for it to sink in too, but like I said, you can if you just print relentlessly, you're gonna get there every time. It's weird, but it works. Okay. So let me get to an overview where we can kind of look at where we're at in the material. All right, so last time we talked about, or last few study halls, we've gone over pretty deeply into mutability, and I kind of tried to give a lot of airtime to ideas of mutability and manipulating lists, creating elements, reading elements from lists, updating and deleting elements from lists as well. Today we're going to go into more list functions and methods. So I skipped the very first one just because it's sort of an overview, and we're just going to go straight into functions and methods here. Cool, it looks like we have a response from... Oh, sorry, no, that was the message that I already responded to. My bad. Okay, anyways. Learning objectives. So by the end of this lesson, we want you to be able to distinguish between functions and methods. So the way this is stated is liable to make one think that there's some similarity, that the two could be easily confused. There is, and that there's, but also that there's like some sort of like big difference in terms of what they do, and that's not really quite the case. Functions and methods play a really similar role. They're pretty similar. They are pretty similar things. In terms of, I don't believe Python puts any limit on one that it doesn't allow the other. So I think it's correct to say that anything you can do with a function, you could do with a method, and vice versa. There are some differences. I mean, we have different names for them. There are some differences. Methods, functions are just like isolated bits of logic. They're procedures that are encapsulated in a function that we can use in various places in our code. Methods are associated with a class. They're always a member of a class. Technically, in Python, if you want to get technical about it, everything is a member of a class, including any functions in your program. So technically, functions are also members of classes, but we don't really think about them that way. And in other languages that have functions and methods, functions aren't members of classes and methods are. So we're still thinking about this not only in the context of Python, but in the context of programming in general. So functions sort of stand alone, and methods belong to classes. Or you could also say they belong to objects. So let's just look at an example, right? Print len. Len is a function. It's a function that's built into Python. Obviously, I mean, print is also a function that's built into Python. We'll look at the len function for now. Len takes in something that has some number of elements, some countable number of elements in it, right? A string has a number of characters. A tuple or a list has a number of arbitrary objects. A dictionary has a number of items. A set has a number of items. So it takes in some object that has some countable number of items, a length, and expresses that, i.e. it returns an integer representing the count of the items in that collection, right? So if I pass a string like hello, I print this out. So len takes in a thing that has a countable number of items, HELLO, that's 5 items, so 5 characters, and it expresses that length as an integer, which, because that's what else would you express it as, right? So I print that out and I get this length, right? So that's an example of a function. Pretty familiar with that. Since we're talking about lists, we'll do that. So this should be 6. Okay. And then let's actually just do this. I'll make this my list. And let's look at a method, right? So I'll say list.append, and we'll get append. What do we want to append? I don't know. Hello, right? So append is a method on lists, and what it does is, I mean, if you're to this point, you probably know what append does, but just for the sake of clarity and for establishing what we're talking about, append is a member of the list class. I can call it on a list because it is part of the definition of the list class. Wherever in the Python standard library, wherever lists are defined, the append method is also defined as part of lists, right? So any list I can call the append method on, right? So we know LST is a list because I made a list right up here, right? So I can say list.append, and just whatever I pass to it gets appended into the list. So it alters the list. So I'm going to append hello to this list, and we can do that there, right? So we'll just print off the contents just to prove that that append happened, and we'll be good to go. Okay, so hopefully there's, some similarity, or some, maybe there may be some apparent similarity between this len here, right, and this append here, right? So both of them have they name some process, either len or append. In either case, they have parentheses after them, and then in either case we pass an argument. So we pass some piece of data, some object as an argument, and then they do whatever they do. Now in this case, len returns a value. What that means is wherever I'm calling it, I can think about len as the value that it returns, right? Append does not return a value. It does something different. Rather than returning a value, it performs a mutation on the list. So it changes some element of the list, right? So technically, functions, you can write a function that will change that could possibly change mutate the elements of a list, right? By convention, you never, ever, ever, ever do that. It's just not done. You're not supposed to do that. So in general, what makes functions useful is that they return a value. Methods, on the other hand, like functions, can cause a mutation to the object that they're called on, the object or the class that they're a member of, so they can cause a mutation. And if you write some code that mutates an object, by convention it should be a method. And again, you might ask, well, why, if I'm making a mutation, why should it be a method? and not a function. And I mean, the short answer is, like I said, because that's convention. It's useful to have somewhat of a clear idea of what tools will cause a change in your data and what tools won't. Not every method will. So some methods, let's look at a different method. Let's say I have 2 3s in here, right? So count, right? Count doesn't cause a mutation like append does. Count works more like a function or a method. I mean, so count. Sorry, what am I doing? I'm counting count. I meant to count 3. So count returns the number of elements of a given type that are in the collection, right? So if I want to know how many 3s are in my list, I'll say list.count3, right? And yeah, so count just takes in inputs and it returns an output. You might ask, like, well, why? Len kind of works a lot like count, right? It just gives you a count of all of the elements. Count gives you a count of all of some specific element, right? So this gives you the total amount of elements, and this gives you the amount of specifically 3s or a specific element, right? So you might ask, why is len a function and count a method? Join the club, right? Why there, to my reckoning, there isn't a good answer to that. There isn't like well, here's why it should be that way. It just is that way, right? So I say this not to confuse or confound, but to give an example of that functions and methods do have a lot of similarity, right? They do have a lot of overlap. Count could have just as well been implemented like print count list 3, and like this would work the same, or could work the same as the method version of count. But why it was done as a method and not a function was just somebody might have a better answer for this than I'm going to give here, but I would argue, I mean, it's essentially just down to a judgment call on behalf of the maintainers of the Python programming language, right? The people writing the language chose to make len a function, and they chose to make count a method because it's their prerogative to do so. So, as you're writing your code, you can decide if you want to write things as functions, or if you want to take a more object-oriented approach and write methods. You'll probably end up doing both. When you're writing classes, you'll probably write methods for those classes, and when you're not writing classes, then you'll write functions. So, okay, cool. So that's that in a nutshell. So to recap here, methods come after some data type, some class, and then a dot to access that method, right? So methods are specific to the classes that they are members of, right? So append is only a method for lists. It's not a method for strings or anything. Count does exist actually for strings and tuples as well, and you use it exactly the same way. Functions are just independent encapsulations of procedures that we can reuse wherever. They give values back. They usually give values back. They usually take values in as inputs. Not always in either case. Yeah. Overwhelmingly, though, they will do one or the other. They will do both, actually. Methods, even though functions can cause mutations, like append, right? that is by convention the domain of methods. And that's just sort of to isolate it down so that you can always count on a function not mutating your data. It's really nice to always to know that like all the functions that you're using aren't going to cause some unexpected change in your data, right? So by convention, we just don't write functions that cause mutations in data, or not on purpose. um, or if you ever did, if there ever was a reason to justify that, you better be prepared to defend it. All right, cool. So let's just go through this. We've talked about how to define functions. This is just an example of a function. I doubt this is going to go into defining methods. This is just talking about calling methods that already exist. Cool. Okay. So I'm just gonna we'll leave it at that, and I'll just do the challenges for this one. Is the code in the second line of the function or line a function or a method? Obviously, I was giving append as an example, so that's a method. Function. Is the code in the second line a function or method? Map is a function. True or false? Methods are applied to an object. Functions are features called in an object. It's the other way around, so that's false. It's actually a really good, nice, succinct description. I'll just go over this, but I'm going to correct it. We'll say functions are applied to an object, right? So we have len, we're applying this function to this object. List is an object. Methods are features called, I would say, from features of an object. Yeah. Let's say members. Members of an object called from within. Cool. Let's do that. Nice and succinct. All right, len and sum. Well, we already talked about len. That's good. And I'm not seeing any questions, so I'm assuming that everybody is retaining 100% of this information with perfect accuracy because my teaching skills are just really awesome. So yeah, I'm assuming it's going well for everybody. Don't feel free, or excuse me, don't. What am I saying? Don't feel bad. Don't feel like you're interrupting if you have a question. The reason I'm doing this, obviously to cover material and stuff, but this is for y'all to ask questions. So please feel free to chime in if something I'm saying isn't making sense. If I'm making a mistake, if you don't understand, feel free to chime in. Okay, cool. So by the end of this, we'll learn how to apply the len and the sum function. I'm just going to give an example of this again because it's real easy. We looked at len. Let's just look at it again. Len's real easy. So whenever you're understanding a new function, think about what's its input and its process and its output. A lot of the time, maybe I would even say most of the time, or generally, the process doesn't really matter. Like len, I don't really care how len determines the length of the list. I can treat it like a black box, right? Like I can, like I hand it a list and it does something and it gives me back a number. So input is a list. Its process is something, and its output is an integer, right? So we'll say input is a list, string, or tuple. I think you can do, yeah, tuple. I think you can do sets and dictionaries. I'm kind of not sure about that for some reason. Oh, now I'm curious. Can you do a set? Can we get the len of a set? Yes, okay, so you can do sets, and I'm going to assume since you can do sets, you can do dictionaries. Okay, cool. So that'll give you the number of items. Okay, so we can also do sets and dictionaries. So len, we'll do this. Len, and you can make. I would even, as an experiment, you could try this out. Every time you encounter a new function somewhere, could be in your text editor or pen and paper, whatever. Somewhere, write it down. The name of the function, input, and then we'll say one input uh, uh, of these types: list, string, tuple, set, dict. And I'm using the type specifier names here. Like, these are Python's official type specifier names for each of those types. Len's process is, you know what? I don't really care. Whatever. I don't care in this case, but you might in some cases. Its output is an integer. An integer representing the length of the input. Cool. So you could describe, in this case, you could describe the process as basically takes processes, it takes a list, gives you a number. That is, at least for our purposes, a sufficient understanding or sufficient process for understanding. You could also add things to this. I've heard other sort of rubrics. Somebody was mentioning something about like input, edge cases, errors, process, output, something like that. Where process comes into play, and where I would think about something having a process is take, like, usually for mutable methods like list.append. List.append takes in, so it's inputs, I would say, a member of list class, right? And I would just consider the class that it's a member of as part of its input, and then I would say member of list class and takes one argument, which is an item to append to the list it's being invoked on. Okay. Its process is that it appends an item, and that's how I would say it, right? Its output, or i.e. its return value. Output is a direct synonym for return in this case, and in most cases. So its process is it appends an item to the list. Its output is none. doesn't have an output. So really, the process of append is more important than the output. But again, how it does that, exactly what it does in order to do that, doesn't really matter. We can still treat it like a black box. But sometimes process might be a place for notes like edge cases and errors, anything of note in that, or you can make different categories. But IPO is what I was taught, input process output, and this is how I use it. This is just a system for taking notes. And when I learned this, I was like, oh, this kind of gives me a nice rubric. Every function that I was learning to that point just felt like everything was out of left field. This does that, and this does that, and how do I have a system for understanding this? There are other systems. You could argue this is, not perfect or not comprehensive, but it gives you a good starting point, right? And from here, you can kind of make it up as you go, fill in things in a way that makes sense to you. But this is just my process, and I literally do this if I'm learning a new language. I will literally go make notes in my text editor exactly like this, IPO, this function name, inputs, process output, whatever. So it's a good place to start. All right. So we know, okay, so I think we know what len does. And let's look at sum. So sum, I see a lot of people get confused with sum. So let's clear something up about sum. Let me get my list. Do I have that? Oh, nice. Okay. So sum sum takes in an iterable collection of numbers, right? So anything that is iterable, anything that can be iterated through, which is a collection, right, of numbers, of numeric values that can be added together, and it gives you the sum of those, right? So the thing that I see people do a lot is they'll have they'll do something like imagine these are parameters in a function, and they'll do something like a, b, and they'll try to pass things into sum like this. You don't need to do this because you can just add them together. So if you think, oh, I need to use a sum function for these two numbers or whatever, you can add them together, or you could just make a tuple out of them like this, or a list like that, or that, and then sum has its proper parameter satisfied, right? So sum has to take in an iterable, and the elements in that iterable have to all be summable. They have to be numbers, numeric values. So if I do this list, then I'll get a sum of 6 plus 3 plus 4 plus 3 plus 8 plus 5, which is 29 evidently. So that's what sum does. Takes in think about it like a list or a tuple, provided that all the elements in the list or tuple are numeric, right? They don't have to be integers. They can be floats. They can be integers and floats mixed together, just as long as they're numbers. Occurs to me to also mention this is often you can, if you have an integer accumulator problem that you can convert into a comprehension, and you still need to end up with an integer, right? Like if you can generate each thing that needs to be added at every stage in the loop, append it to a list, you can turn that into a comprehension, and then you can just sum the comprehension. So that's a common, right? And comprehensions are a bit out of the scope of this lesson, but for those of you who are at the point where you're working on comprehensions, I'll give an example. we could say in list, right? And this will be, if I wanted the sum of the squared numbers, I could write this like for I in list total plus equals I squared, and I'll start total up here at 0, right? And then, maybe this is in a function and I wanted to return that or do something with total. Or I could say total equals that, right? These are the same logic, essentially. Some people will say, well, comprehensions are always better, you should use them, but I don't know. If you know how to do things this way, then you know how to, you're coding, congratulations. So, yeah. But for those who want to know more about comprehensions, there's that for you. All right, let's knock out some of these. So given the following list, it looks like we got another question here. I'm going to go through, I'll just go through the rest of these and I'll take that question. Given the following list, enter its length. Okay, so list of lists has one list and another list. So it has two elements in it, so that's 2. Right, so notice, I forgot to mention this. Because it's easy to see, oh, well, since this is a list of lists, maybe the outer list, inherits the lengths of the inner lists, right? Each of these inner lists has 3 elements in it. So maybe there's 6, since there's 2 inner lists, maybe there's 6 lengths. But since there's also 2 lists, maybe it's 8, right? No such complicated thought needs to go into this. What you do, and then another list. Whatever those lists contain doesn't matter in terms of calculating the length of the outer list. Makes it nice and simple, right? Given the following code, what will get printed to the console? List to sum. All right, well, I'm not going to sum those in my head. It's much easier to just get Python to do it for me. Nine, 3, 4. Okay. Given this list of daily high temperatures, calculate the average. Right, so remember, average is the sum of the events in a collection, the numeric events in a collection, over the length of the collection, number of items in the collection. So sum over length is sum of list over length of list is the average of the list. So let's do this one. Daily temperatures. So the average daily temperature across the period that this list tracks is print sum daily temps over len daily temps. 58. Okay. 58.5, whatever. Give the exact answer as appears when you calculate it in Python. Okay, good. So we need that whole thing. Sorted and reversed. Oh, sorry. We got to take this question. Let me pop over here and take this question. Number 18 on the list methods. Copy the link. Okay, so we have some code with this one. Let me paste in the code, and I'm going to paste in your copy as well here. Okay, I would like to click, please. Okay, thank you. I don't know what it is with this Mac. Sometimes it just starts ignoring my mouse clicks. I'm like, all right. Okay. Okay. Find shortest word amongst mixed elements. So this is the question. It says this code works, but I think there's probably a way to set my min len variable to the length of the longest string in the input list. Am I correct? If so, could you explain how I would do that? Oh, so you want to set it equal to the longest string and then compare it down from there? It sounds like. Um, oh no, no, don't worry about asking multiple questions. That's fine. I appreciate the interaction. That's fine. Um, okay, so could I explain how I would do that? So, okay, so let's see. There's probably a way. So I'm just gonna to set the minlen variable to the length of the longest string in the input list. So yeah, it looks like the request is just for me to give kind of an analysis of this. Yeah, I'm going to run it. I believe you that it works, but um, we'll just go through it. And this is number 18, 15, 16, 17, 18. Okay. I feel like I helped someone with this one mere days ago. Okay, so this does work. Oh, I see. So you're just setting a really high, uh, you're setting an upper boundary, right? So you're banking that there's the shortest word is not going to be more than 1,000 characters. Um, this is definitely a hack, and that's I love a good hack. I just love a good hack, and this is a great hack. Um, so yeah, I get I don't know I kind of like solutions that are just like, well, it's gonna work, you know. So kudos to finding a way to get it to work. You know, good problem solving. But let's look and see if perhaps there's a more elegant way to solve this particular problem. So, oh god, I think it was just days ago that I mean like earlier this week that I helped somebody with this particular problem. Maybe it was Friday, but I need to go through it again. Okay. So I'm just going to, oops, I'm just going to comment this out and kind of start on a solution here. Or I'll have that as a reference. Actually, maybe I'll do a solution after this. So if I look for element in array, element is a string. Okay. So this function, given a list, this function should return the shortest string within the given list. Okay, so we have to first, we have mixed elements. So we have to determine if a number is a string, and or if numbers, if a given element is a string, and if it is a string, if it's shorter than the shortest known string to that point. Okay, a couple of things here. I see this if, right, if array equals list or empty list, return empty string. So this is an edge case, and we don't need to check this. We only need to check this once. We don't need to check it every time we run through the loop. It's a minimal amount of computational power, but in terms of good practice, in terms of writing a cleaner solution, in general, you check your edge cases as soon as you can, right up front as the very first thing in the function if you can get away with it. There's certain times where you have an edge case and you kind of need to do some other work first and then see if something matches your edge case, and then take that from there later on in the code. But in general, you can get away with doing it right away. Okay. I feel like, oh, okay, that's what it is. Okay, I was like, the syntax highlighting is off. That's because I took away that if, right? So we can make this an if. Okay, so this tells me if the type of the element is not a string, then continue. That's fine. Else, this is if the type of the element is a string. We can save a couple lines here, not a big deal, but we'll just check if it's equal to a string, and then we'll take the else code, right? Because it's either true or false that a type is or isn't a string, which means all the code in here is for if it is a string, right? So else it is a string. So I'm just going to do this. This is going to work exactly the same way, because if the type is not a string, then it's just going to ignore all this, and it'll find the end of the loop, and that's a de facto continue, basically. So that's another thing we could do. Then we could say if the length of the element is less than men len. Okay, so here's what I would do. The question posed before was how to set men len equal to the longest string, and then from there you always have your your upper boundary established, and you can pare it down from there. That it is actually easier to find the longest string than the shortest string, but it's actually such a similar process to this that we'd be basically duplicating the logic, like going through the whole list to find the longest string. We could start min len. We could do this. We could say max len, right? And then basically go through this process. The reason it's easier is because we know a string can't be less than 0, right? So we'll start max len. We'll just assume 0. We know there's there isn't a clearly defined upper boundary for how long a string can be, but there is a clearly defined lower boundary for how long a string can be, right? So we could say max len equals 0, and then basically just go through this whole process just in reverse, like check the opposite conditions, right? But we're duplicating the logic, and we can do it this way because that was particularly the question that was posed. So I'll say for element in an array, if the type of the element is a string, and if the length of the element is greater than max len, then max len equals len element. Res equals element, right? This will get us the max len, which we can then use. We could just say min len equals max len. We'll start min len down here, right? Since I'm doing this, this is just for semantic reasons, right? I could start this as min len here, and then use min len, right? But since I'm literally starting at 0 and calculating the maximum length, I don't know, just makes more semantic sense to call it maxlen, and then just do an arbitrary swap right here and just say, okay, now minlen equals the longest one, so we can find the shortest one. So this would do it, but the problem is I've doubled this for loop. So there's sort of a better shortcut that I can do, which is I'm just not going to initialize minlen right here. What I'm going to do is I'm going to say, so if the type of the element is a string, if min, actually no, excuse me, I will, I'll initialize this as none. We'll do that. So if min len equals none, right? So we don't have a min len yet. We're just going to start it at none. So if min len equals none, then min len equals length of the element. Yeah. Elif. And I think, can I just do this? Yeah, okay. So this is actually the same code. So I think like the consequence of both of these conditions is exactly the same. So I can just do this. If minlen is none, or the length of the element is less than minlen. Yeah. Then we can do this. And I'm just going to comment this out for now. We'll see if this works. I don't have any tests, I just realized. Too lazy to write them. I'm just going to see. I'll just see if that works like this. It's kind of a mess, but whatever. That should work, I believe. Nope. Where did it go wrong? Res variable referenced before assignment. I commented out res. Didn't mean to do that. Okay, so that works when I make res exist. Okay. So, yeah, this is something like this is what I'd prefer as a solution. We only have one loop here, but to answer your question in the terms that you stated it in, we need basically two loops. There are ways that you could like condense these down. We could use comprehensions or map, but in either case, like we don't like those will in practice, comprehensions or map where they can be used over a for loop. Sometimes you need to use a for loop over one of those, but where they can be used, they stand a good chance of being more performant. And there are various reasons for that. But in terms of like computational complexity or big O notation, when we're analyzing a solution in terms of its computational complexity, its big O story, it doesn't matter whether we're using loops or comprehensions or map. We still think about those as exactly the same. We still think about that as the same computational complexity. So, like we could make these better loops and get some practical benefit out of that. But that doesn't change the computational complexity. So at the end of the day, like you could write this more succinctly. you could write it more elegantly with map or comprehensions, but it's still, you're adding that whole other step of uh, of looping through the whole array, essentially. Cool. All right. It looks like we've got another question. This is our normal stopping time. However, that's not necessarily set in stone. I'm gonna just let me just take a look at this, and if it's a long one, I might have to sync up with you later. But we'll take a look at it real quick. If it's a short one, then I don't mind going over it. Or if it's an interesting one. Okay. And if anybody has any questions about this last problem, feel free to ask that as well. We don't necessarily have to just be done. Just because I'm moving to the next one doesn't mean we're done with that. And let me know if that's also, to the person who asked, let me know if that was helpful or if you're still confused or something. Cool. Oh, somebody's in Austin. Okay, wow. Yeah, you're having a go of it, I hear, down there. Hope y'all stay safe. All right. So list accumulators number 3. Looks like I've done this one. Is it divisors? List accumulators, question 3. Okay. I'm just going to assume it's divisors. So I do have, ignore the code there. You don't see any code. There's no code to see. All right. I have a solution there from before. All right. So we'll write this function in terms of its docstring, or against its docstring here. So return a list of proper divisors of n. Proper divisors, I think, just don't include n or 1. So parameter is n, a positive integer, and it returns a list of proper divisors of n, where a proper divisor is any number which is a divisor of n, but not n itself. I wonder if 1 is included in that. That's okay. Cool. Okay, glad to hear that that previous question was helpful. Thank you for letting me know. That's helpful. If you let me know, I'll always ask just to make sure either way. But yeah, do let me know if when I give an answer to a question, if when I get to the end of it, or let me know if you're like, I like, okay, that works, but I still don't understand what's going on or whatever. If you have any other follow-up questions, or if you're good, and that helps me know that what I'm doing is useful. Cool. So appreciate it. All right. Let's get back to this one. So for this one, I'm just going to assume we got a list accumulator here. We'll return list, and we'll say for I in range 1, 2, and I think, so this says a proper divisor is a divisor of n that is not n itself. Every number is divisible by itself. N over n is 1, and n over 1 is n. So I'm assuming that 1 would not be a proper divisor as well, since it's literally a divisor of every whole number. But it doesn't say that, so I'm going to start at 1, and it might yell at me, and I'll have to fix that. Okay, so we'll say 1 to n, so 1 is included, n is not included. The reason I can't start at 0, you might know, you can't divide a number by 0, it's not a thing. At least in Python, it's not a thing. You could debate about what that would be in higher math, but there is a debate about what that is. Python's opinion is that it doesn't know how to divide by 0. So when you're planning on dividing numbers in a range, which you do fairly frequently, you want to make sure you're not dividing by 0 because Python will freak out, or it'll just throw an error. Okay, so for I in range 1 to n, if in mod I equals 0, meaning n over I has a remainder of 0, then I is a divisor. So we'll list.append I. Yeah. And pretend like this isn't exactly the same code. Okay. We'll see. I tried not to look at the code from before. Okay, it looks like it's good, and I think it was exactly, yeah. So I just had a couple different names. I called it factors list and div. So it looks like it does include 1 for this one. Cool. Let me know if that was helpful. And yeah, I'll give a second for questions, but I think that's good, unless I'm missing something about this one, but I think we're good. We can wrap up here. Yeah, I'm not seeing any questions coming in, so I'm going to assume everybody's good to go. Oops. Cool. Yeah, it's easy. It's easy to get things overcomplicated. If you saw how I approached that modulo problem initially, right? It's just something that happens. I would say it's such a common problem to like think something is more complicated than it is. Just try to like develop a gut feeling for it. Be like, if you're like starting to dive into a rabbit hole, like ask yourself at some point, like, does this feel right? And you'll probably get a sense after a while of like of that. I think I think that can help. And there's times where you just need to be like, okay, I feel like I'm going down something. Just comment out your code or delete it or put it somewhere else and then start over. Happens to the best of us. Cool. All right. Hopefully everybody had fun. I know I did. This is I always enjoy doing study halls. Look forward to the next one. Next one will be on Friday, and look forward to seeing you all there. Go ahead and give us a like, comment, subscribe on YouTube. That helps us out. Of course, if you didn't like the video, then you can give it the old thumbs down. And, admit to the world that you sat through the whole thing and didn't enjoy it. But that is your prerogative, and that's what that's there for. Yeah, look forward to doing this again, and I'll see you soon. Cool. Bye bye.